to today's lecture. Today we want to look at the assignment problem. The assignment problem. The assignment problem. The assignment problem is a special case of the transportation problem. It arises in a variety of decision-making situations. Typical assignment problem involves assigning jobs to machines or jobs to people, contracts to bidders, etc. Now, a distinguishing feature of the assignment problem is that each machine or person or bidder, contract bidder, is assigned to one and only one job or task. Now, the main objective here is to do the assignments in such a way that the total time taken to perform the jobs is minimum, or the cost involved in performing the job is minimum. Because if you are minimizing time, you can minimize time, and you can also decide to minimize a cost. And when you are minimizing cost, indirectly you are maximizing profit. So this is typically what the assignment problem is. You want to assign jobs to some people to do, to perform. People who are equally competent to perform. So how do you assign the jobs in such a way that the total time taken to perform the jobs will be the minimum? Yes, if you are talking about hours, it means that you want to use a minimum number of hours to perform the job. Okay, now to understand this better, let's look at a question. Let's look at a question. 4 workers are available to perform 4 jobs. The time it takes each worker to perform each job is given in the table below. This is a table. This is a table. You can look at it later. The goal is to assign jobs to workers so as to minimize the total time required to perform the 4 jobs. So let's look at the table. This is a table. We have worker 1, worker 2, worker 3, worker 4. There are 4 workers and there are 4 jobs. And as I've already indicated, here every worker will be assigned to one and only one job. Yes. Now, this is the time in hours. Let me explain the table. Worker 1. Worker 1 is saying that to perform job 1, it will take him or her 10 hours. To perform job 2, it will take him or her 15 hours, and so on. Now, let's look at, let's say, worker 3. Worker 3 is saying that to perform job 1, he or she will need 12 hours. 9 hours for job 2, 15 hours for job 3, and then 18 hours for job 4. So this is the explanation of the table. So, as an operations researcher, how do you assign the jobs to the 4 workers so that at the end of the day, the total time required or the total time used to perform the jobs is minimum or is optimal? Okay, so let's look at it. Now, to do this, you are going to employ what we call the Hungarian method. Hungarian method. Hungarian method. The method were Hungarian method. Hungarian method. This method was developed by Kant in 1955. It was Kant who came out with this method, the Hungarian method. So we are going to employ this one to solve this assignment problem. Okay. So let's look at the solution. You can solve it here. So solution. and you are using the Hungarian method. Hungarian method. This is the method you are using, the Hungarian method. Now look on the board. The first thing to do is what we call row operation. Row operation. Now the row operation, this is what you do. You look at the table that has been given to us, look at it. You see that this is the first row, second row, third row, fourth row. So the row operation, what you do is that you look at the entire table. For example, the first row, you look at the first row. Identify the smallest number in that row. Are you seeing it? So here, the smallest number in this row is 10. I hope everybody can see it. The smallest number in the second row is 8. The smallest number in the third row is 9. And the smallest number in the fourth row is 6. So what you do is that for the row operation, what you do is that for each row, you take the smallest number in that row and subtract it from each of the numbers in that row. Again, for the row operation, what you do is that for each row, you take the smallest number in that row and subtract it from each of the numbers in that row. So if you look at the first one, the smallest number is 10. So if you subtract 10 from 10, you are going to get 0. 10 from 15, you are getting 5. 10 from 12, you are getting 2. 10 from 17, you are getting 7. The next row, the smallest number is 8. When you subtract 8 from 12, you are getting 4. 8 from 8 will be 0. 8 from 22 will be 12. 8 from 16 will be 8. The next one, we have the smallest number is 9. 9 from 12 is 3. 9 from 9 is 0. 9 from 15 is 6. And then 9 from 18 is 9. And the last one, the smallest number is 6. When you subtract from 12, you get 6. 6 from 6 is 0. 6 from 15 is 9. 6 from 20 is 14. So this is the row operation. This is the row operation. You are done with the row operation. Now from here, you move on to what we call column operation. You are solving it. You are solving the problem. These are the steps. Column operation. Now, for the column operation, you see, this was the question. That we have to get the row operation. So you have to continue from here. You don't go back to the question. You have to continue from here. You have to continue from here. Okay. Now, if you are continuing, what you do is that for the column operation, you take for each column, you are here. You don't have to go back. So for each column, you take the smallest number and subtract from each of the numbers there. So the first one, look at the first column. Because it has 0 here, if you subtract 0 from each of these, you are going to get the same thing. So 0, 4, 3, 6. So what it means is that if you have 0 in a column, you don't have to think. You just have to repeat the numbers. So this one too, I have 0 there, so I'll just repeat the numbers in that column. Are you seeing it? And then the next one, this column, the smallest number is 2. So you subtract 2 from 2, you get 0. Subtract 2 from 12, you get 10. 2 from 6, you get 4. 2 from 9, you are going to get 7. The next one, the smallest number is 7. Subtract 7 from 7, you get 0. 7 from 8, you get 1. 7 from 9, you get 2. 7 from 14, you get 7. So this is the column operation. You see that it is not difficult at all. This is the column operation. Okay. Now, when we are done with the column operation, the next thing to do is this. The next thing to do is this. We are going to cross out all the zeros using the least number of lines as possible. Again, we are going to cross out all the zeros using the least number of lines as possible. What this means is that if you can use straight lines to cross out all the zeros, and then you intentionally use 4 lines to cross out all the zeros, you are going to get it wrong. To be wrong. So you have to try as much as possible to use the least number of lines to cross out all the zeros. So look on the board. You are going to cross out all the zeros. Now look on the board. So to do this, you have to look at a column or row with so many zeros. So you can see that if you look at this column, you can see that this column has 3 zeros. And then this row also has 3 zeros. So I can just cross out this row. Are you seeing it? I can cross out this row, this column. Don't say that, so you can cross out this row like this. Look at it, I'm crossing it out. I've used 1 line to cross it out. And then I can cross out the zeros here. So I've used 2 lines. Now, if you had done this, look on the board. Somebody would have just done this. Use 1 line to cross this, 1 line to cross this, 1 line to cross this zero, 1 line to cross this zero. That would have been 4 lines. And that would be wrong. That's why I'm saying that you have to use the least number of lines as possible to cross out all the zeros. So now you have crossed out all the zeros using 2 lines. And the lines should be vertical or horizontal. Yes, you don't use diagonal lines. So you can use vertical lines or horizontal lines. That is okay. So now look on the board. You see that I have used 2 lines to cross out all the zeros. Now when do you stop? You stop when you see that the number of lines you have used to cross out the zeros is equal to the number of rows or columns or jobs or workers in this case. So when the number of lines you have used to cross out all the zeros is equal to the number of rows or number of columns, then you can stop and start doing the assignment. Okay, so here clearly you can see the number of lines is 2. I see 2 lines. And it's not equal to the number of rows. There are how many rows? 1, 2, 3, 4. And then 4 columns. So the number of lines is not equal to the number of rows or columns. So we have to continue. So let me clean this side, because the question will be needed in the final lesson. So let me clean this. You can come here and see. Now to continue, you do what we call redistribution of zeros. Redistribution of zeros. You are going to redistribute the zeros. Now, so look on the board. You cannot stop because you have used 2 lines to cross out all the zeros. If you're able to get 4 lines, you have to stop. Okay. Now, how do you continue? How do you redistribute the zeros? Look on the board. You see that I have crossed out these numbers. So these are the uncrossed numbers that have not been typed, the untyped numbers, the uncrossed numbers. Are you seeing it? So these are the uncrossed numbers. Now to continue, what you do is that you take the smallest uncrossed number. Let me write it so that you see. You take the smallest uncrossed. These numbers have been crossed, have been typed. So the smallest uncrossed or untyped number, so in this case, it will be 1. I think this will be the smallest uncrossed number. When you take this number, you subtract it from all the uncrossed numbers. You subtract it from all the uncrossed numbers and add it to the junctions. Now, the junction is formed when 2 or more lines meet. Do you see? So for this one, look at it. This is a line. This is another line. So these 2 lines have met here. So this is a junction. The 5 is a junction. So what you are saying is that you take the smallest uncrossed number, which in this case it is 1. Subtract it from all the uncrossed numbers and add it to the junctions. So we are going to add this one to the 5 and subtract it from each of these numbers. Are you seeing it? Okay, so let's continue. So if you do that, you're going to have 0. 0 is not a junction. 5 is a junction, so we are adding the smallest uncrossed number to it. So to make it 6, this 0, are you seeing it? Now, this 4 is an uncrossed number, so we are subtracting the 1 from it. So this is 3, this is 0. We subtract 1 from 10, that would be 9. 1 from 1 will be 0. Subtract 1 from 3, 2, 0. This will be 3, 1. Subtract 1 from this, 5, 0, 6, 6. So we have taken the smallest uncrossed number, subtracted it from all the uncrossed numbers, and added it to the junctions. So there is it. We have it this way. So having obtained this, you have to cross out the zeros again using the least number of lines as possible. So how do you do this? So look on the board. So I have 3 zeros here. So I can cross out the zeros here using one line. I have 3 zeros in this row. I can cross out the zeros here using this one. And then you see that I'm left with only 1 0 here. I can decide to cross it this way or this way. So let me cross it this way. Are you seeing it? Now, the number of lines we have used is 3. It is still not equal to the number of rows or columns. So it means that you have to continue. So you are going to continue. So continue. Redistribution of zeros. Redistribution of zeros. You have to redistribute the zeros. Okay. So you are continuing the same fashion, the same manner. So you take the smallest uncrossed number, subtract it from all the uncrossed numbers, and add it to the junctions. So for this one, let's identify the junctions. 6 will be a junction where 2 lines have met. 0 will also be a junction. The smallest uncrossed number in this case is 2. Yes, look at the uncrossed numbers. It's 2. So we are going to subtract 2 from each of these uncrossed numbers and add it to the junctions. So we are going to get 0, 8, 0. This is a junction. So I've added 2 to 8 to make 2. 0 plus 2 is 2. The next one, I'm subtracting 2 from 3. 1, 0. Subtract 2 from this, 7, 0. But this is not a junction. 0, that's 2 minus 2. This is 0. 2, 3 minus 2, 1. This is 1. Subtract 2 from this, 3. 3. This is 0. And then subtract 2 from this, 4. Subtract, no, we are not subtracting anything. This is not a junction. So we have it this way. So here, we are going to still cross out the zeros using the least number of lines as possible. So look at it. How can you do it? You can just cross out all these zeros with one line. You can also decide to cross out all these 2 zeros. And then what again? If you cross out this way, so you cross out the zeros this way, the left with 1 0, you cross out like this. So you can see that now the number of lines is what? 4. So the number of lines is equal to the number of rows or columns. So it means that you have to stop and start assigning the jobs to the workers. You have to start doing the assignment. Are you seeing it? So have it this way. So have it this way. Now, when you are stopping, how do you do the assignment? You do the assignment at where the zeros are. This one is 1. At where the zeros are. So where you see the zeros, you can do the assignments there. And now let me tell you this one. Let me give you this trick. When doing the assignment, start with a column with a minimum number of zeros. Again, when doing the assignment, you have to start with a column with a minimum number of zeros. So I'm going to do the assignment. This column has 2 zeros. This column has 3 zeros. This one has 1. This one has 1. So I'll start with a column with a minimum number of zeros. So I can start with this one and do the assignment. When I do the assignment, I can do something like this. So a triangle. So I can assign here. So I'm done with these two columns. Now, these columns had one 0 each. So let's look at this one. This one has 2 zeros. This one has 3. So straight away, we have to come to this one. Now look on the board. Every row or column should have only one assignment. So because I've done an assignment here, I can assign any job here again. You see it? And I can't do any assignment in this column. The same way I cannot do any assignment here, and I can't do any assignment in this column. So we want to continue with this one. This one has 2 zeros, this column. And you can see that because I've made an assignment here, I can't assign any job here. So I have to come to the other one. No assignment here, no assignment here, so I can do the assignment here. And then move on to the one with 3 zeros. Because I said I have to start with the one with the minimum number of zeros. So 3 zeros. Now, can you do assignment here? You can't do assignment here. Look on the board, you see? Because there's an assignment here. You can't do an assignment here because there's an assignment to that row. So straight away, you have to do the assignment here. You have to do the assignment here. Now, when you are done with this, then you can say that, therefore, the optimal assignments are, you are finished. So therefore, the optimal assignments, are, so what it means is this. So I can clean this. Now look on the board. These are the optimal assignments. What it means is, you see that the first row corresponds to the first worker. So what it means is that worker 1, will take which job? Look at it. Look at worker 1. 1, 2, 3. Worker 1 will take job 3. So worker 1 will take job 3. And this is equal to how many hours? So to know the hours, you have to go back to the original question. Look at it. 1, 2, 3, job 3. Worker 1 is going to use 12 hours. So you go back to the original question to write the hours that will be needed to perform that job. Now move on to the next one. Worker 2 will take a job. Look at it. 1, 2, 3, 4. So you go back to the question. 1, 2, 3, 4. 16 hours. So worker 2 will take job 4. And you will need 16 hours to perform that job. Worker 3 will take job 1. And then you will need 12 hours. So 12 hours. And then lastly, worker 4 will take job 2. And you will need 6 hours. Look at 1, 2, 6 hours. So the total hours needed for this job would then be this plus this is 28. Okay, let me do it this way. This is 24. 24 plus 16. This 2 will be 24 plus 16. That is 40 plus 6. That is 46 hours. So it means that the total hours that will be needed to perform the 4 jobs is 46. And this is the optimal hours. Optimal hours that will be needed. It means that nobody can use hours less than 46. Nobody can use something which is less than 46 hours. No, nobody can use that to perform the job. And look on the board. You can see that all the 4 workers have been assigned one and only one job. And this will be the optimal time needed to perform the job. So this is basically what the assignment problem it's about. You have employed the Hungarian method to solve it. It's not difficult at all. It's not difficult at all. Thank you very much, viewers, for your attention. For more of this video, subscribe to my YouTube channel, Shamalaa Jnr.